Let's study the passive sign convention rule for power. We know that power is the product of the voltage times the current. The rule says that if we have a current that is directed into the terminal with the positive polarity, then if we have a product of voltage times current that is positive, then this will be absorbed, expended, or delivered power. But if the product of voltage times current gives us a negative value of watts, then this element will be generating or supplying power. Now let's take a closer look to the rule. We need to follow some steps. Here we have this element. The 2 amps current is pointing into the positive terminal, and we have this voltage with this polarity. So first thing we need to do is we select the terminal with the positive polarity, in this case right here. Second, in order to write the value of the voltage, we need to look at the voltage in terms from terminal A to terminal B, and we see that this is negative. So when we enter that value into the parentheses, will be minus 5 volts, like that. Now, what is the polarity or the sign of the current? Well, we follow the rule. If the current enters the positive terminal, and it does, the value of the current should be entered with a positive sign. But if the current exits the positive terminal, then his value should be entered negative, and this is not the case. This enters the positive, exits through the negative, and so it should be entered positive, and it will give us up. Minus 5 times 2 is minus 10 watts. If I express this as absorbing, I will have to say that this circuit element is absorbing minus 10 watts, since power absorbed is usually positive. If I express this as power being supplied, knowing that power supply is negative, then I can say this circuit element is supplying plus 10 watts. One more example. First step, we need to select the terminal of the circuit element that has the positive sign, and is this one right here. So that will be our point of reference, so that now I can write the voltage polarity going from terminal A to terminal B to terminal A, and I see that this is a positive voltage, and that positive voltage is entered into the parentheses. Now we need to determine the sign of the current. If the current enters the positive terminal, let's check, it does not. It actually exits the positive terminal. Then the rule says that if the current exits the terminal with a positive polarity, then the value of the current needs to be entered negative, and so that will be plus 5 times minus 2 will give us minus 10 watts. And if I express this as power being absorbed, this will be minus 10 watts being absorbed. Or if I express this as power being supplied, this will be plus 10 watts of power being supplied. Now let's look at the equation of power. Power can be B times I. Now, if I look at Ohm's law, is that voltage is equal to R times I. But I can also express this as voltage divided by R. So if I put this equation here, this means that I'm going to be multiplying R times I, and it will be I squared times R. Now, if I enter this equation in here and substitute I over instead of and put B squared divided by R. Now, the power in terms of G, or conductance is just the inverse of resistance. So if we have voltage as resistance times current, voltage when we talk about conductance will be 1 over G, or current, that it usually is B divided by R, will be G times B. And so if now I substitute these values into my equation, where I can substitute b like that, then that will give me I squared divided by g. Or if I substitute the I, this would give me a value of g times b squared.